Hey guys, this is Math 2, Unit 5, Lesson 5, Conditions for Rhombuses, Rectangles, and Squares. For today's little lesson, looking at the homework help here for you guys, really want to talk through some things that are in here more than working them out to kind of explain why it works a certain way. It's helpful to kind of recognize the elements of a square and which parts are going to be equal to each other and what's going to be similar there. Recognize again that with a square, your parts on the diagonal line, they're going to come across a square and rhombus and form a right angle in the middle. You're going to have matching parts on both sides. Those are going to be equal to each other, as are these going to be equal to each other when you look at the diagonals. When you do a rectangle, these angles are going to bisect each other, but it won't be a right angle. Instead, you'll end up with sets of equal parts on the opposite point, so the midpoint here, and you'll kind of solve from there. So you have some adjacent sides that say that are congruent, and that's a little difference between the two. When we're looking at actual shapes and having to solve them, what it helps me just remember and know is that, okay, when I have a 5x minus 15 on this side and a 3x plus 9 on this side, and it's a rectangle, because it's a rectangle, these lengths are going to be equal. And because they're intersecting in the middle, even the middle points are going to also be equal. So to set this up, I would say that 5x minus 15 equals 3x plus 9. Like it says, write an equation for the congruent segments. Those are going to be equal to one another. So once I've set that up, then I would go ahead and solve algebraically for x to find out what x is going to be there. I'm not going to do that for now. I just kind of want to talk through this here with you guys, because some are a little different. When you look at a rhombus, like we said in our last lesson, when you have a rhombus, these sides are equal, and when you cut this in half of the rhombus, the angle bisects, and you end up with an isosceles triangle. The way I look at this one here is that if this angle is 2x plus 1, well, so is this angle. It's also, 2x, minus 1. My apologies. 2x minus 1. If I'm going to figure out what the value of x is, if this is 2x minus 1, and this is 2x minus 1, and this is 4x plus 8, I know that the sum of all three is going to be equal to 180. So to set up an equation, let's just jot it over here because I have more space. You could say something like 2x minus 1 plus the other 2x minus 1 plus the top 4x plus 28 will all equal 180. I could combine my like terms, right? Combine my like terms, put them together, and then solve for x. And that's what it's asking you to do there. When I look at the square, because with a square, the diagonal bisects the angle, I already know that this angle here is 90 degrees, the whole thing. Because it's a square and I'm cutting it in half, I know that half of 90 divided by 2 is equal to 45. Well, they're asking about 7x plus 3. So guess what? 7x plus 3 is going to equal 45. Now I have a new equation to solve. Number 9 is similar to what we did before. We want to show that these two sides are equal, so we make a congruent statement with these two segments. The same is also true for this rectangle. I would set this line equal to that line and set up another equation to find the value of x. Looking at the back side of your work for tonight, we get again the same type of deal. Because this is a rhombus and where the diagonal bisects the angle, we know that 2x plus 16 is going to equal 3x minus 2, and that's because it's a rhombus. Then we can set them equal and solve for x. This is also, again, a rhombus, so we'll do the same thing. Set these two equations equal to each other and solve for x. The rectangle, like we did on the front side, this forms a right angle when you bring these together. Remember, a rectangle doesn't bisect it perfectly into two equal parts like a rhombus does. So, in this case here, I'm going to set up an equation 4x minus 12 plus x plus 2 and set that equal to the value of those two angles combined. And because it's a rectangle, I'm going to make it equal to 90 and solve for x. Okay? This rhombus is a little fun because now we have two different angles. I'm not sure what they are, but because we know that when the diagonals bisect in a rhombus, where they intersect, it forms a perpendicular line. We know that we have 90 degrees right there in the middle of number 14. And again, our angles all have to add up to 180. So I could take a 90, I can add to it a 2x minus 13, I could add to that a 7x minus 5, and I could say it's all equal to 180, and now I'm back to solving for x. So I'll let you work that one out as well. Again, down here, similar idea. We're looking for these things are going to be corresponding angles. They're going to equal each other. So I set them equal to each other, and I solve for x. All right? So you kind of get the idea there of how that works. There's some work for you to do in this page, but I wanted to give you a feel for what that looks like.